In this video, we will work on this problem. So let us look at the thought strategy first. So read the problem and see what is happening, right? Then look at the options, get an overview, see if there is a pattern between the options, and then proceed. So in this problem, you have a wire and a constant current I is flowing through the wire, right? Here you have a wire and there are two rails. They are parallel to the wire and those rails are connected by a resistance R and a capacitor C0. And then you have a semicircular conducting rod connecting these two parallel wires, and that rod is being moved upward with constant speed V. Now if you look at the options A and B, they are about maximum current, so only one of them will be correct. Option C and D, they are about maximum charge, so only one of them will be correct. And also note that this problem has RC circuit. So you should be mentally ready with all the formulas that you should know for RC circuit. Now, maximum current. So the current will be due to voltage. So where is that voltage coming from? So because of the current in this wire I, you will have a magnetic field around the wire like this, right? And through this yellow area, right, the flux passing through the yellow area is changing over time, and that will create EMF, right, because of law of induction, right? And that voltage is the how fast the flux, the magnetic flux is changing over time. So let us find out the rate of change of flux. Rate of change of flux will depend on the change in magnetic field, and here the magnetic field is not changing. It is the area that is changing. So if you look at, as the rod, the semicircular rod is moving up, so in dt time it will travel a distance of v dt, and this area here is the area that is adding to the flux, right? So the flux through this highlighted area is the change in flux. So let us find the flux through that area, right? So you can take, so first of all, the magnetic field due to a current in a wire, the formula is mu I by 2 pi x at distance x, right? And you will integrate it from x equal to 1 to x equal to 4, right? You integrate it and then you multiply it with v dt, right? Now if you integrate it, you will get a logarithmic function. And also note, you have d phi on the left side and you have dt on the right side. So if you bring dt to the left side, you will get d phi by dt, and that is 1.68 into 10 to power minus 6 volt, and that is the voltage created, right? So now this here, it is, you can think of RC circuit with a battery V and resistance R and capacitor C0. V1 minus V2 is the voltage across the resistance, and V2 minus V3 is the voltage across the capacitor. Ohm's law for resistor IR, and for capacitor it is 1 by C integral I dt. So maximum current, so at time 0 there will be no current, there will be maximum current, and this value will be 0, right? Because the integral from 0 to 0 will be 0. So at time 0 this will be 0. So you have I into R equal to V. R is constant, so maximum current will be V by R, and that will be 1.2 microampere. So A is correct and B is incorrect. C and D about charge on capacitor. So the formula for that is Q, charge on capacitor, is C0, capacitor constant, multiplied by the voltage across the capacitor, V2 minus V3, right? V2 minus V3. So Q max will be C0 is constant when V2 minus V3 is max. And when will be that maximum? As the time approaches infinite, the current will drop because the charge is being accumulated on the capacitor plates. So eventually the voltage across the capacitor plates will be V, and that will give you maximum charge C0 V. V is the EMF, right? And that will be 8.4 multiplied by 10 to power minus 12 coulomb. C is correct, D is incorrect.